So the example that we'll use for the first part of this is to round the whole numbers 23, 47, and 55 to the nearest 10. But in order to do that, we first need to take a little background and understand what place value is. For example, if we've got a bunch of items, beans in this case, and we want to represent them, one way to do it is to just have a picture of it, an image like we have down here, right? We could just draw pictures of this many beans anytime we wanted to talk about that idea of how many we've got. But of course that's very inefficient. And so somewhere along the line people came up with the idea that we could assign symbols, like this symbol right here, to represent some number of items of anything, and it can be anything. So we have this idea of being of one thing, and we'll use this symbol to represent one of anything, not one bean, but one anything. And we extend that and come up with another symbol to represent two items, which is two of these things, representing as a picture here. And of course we kept going and started assigning these different symbols for different numbers of items. But if we continued like this, we'd need a new symbol for every number of items that we needed to talk about, and that would be hard to keep track of. And so I guess because we have 10 fingers on our hands or 10 toes on our feet, or for some reason, when people got to the next number bigger than this, they decided to shift gears a little bit. So here we have one more than 9, and the question is, how shall we call this this number of items using our abstract symbols? And what came up was to recognize that we can group these as one group of 10. So in order to do that, though, we also need this idea of 0. And that actually, the number 0 came in way after the counting numbers. And it was necessary, partly, in order to represent this as one group of 10 plus 0 units, 0 singles here. So we're going to name this number of items one group of 10 plus 0 singles, and we're going to write now a 2-digit symbol where the highest order digit, the one furthest to the left, represents the largest number of groups, the largest size groups, and the smaller groups are successively to the right. So in other words, this 10 represents one group of 10, or 1 times 10, plus 0 units, 0 times 1. And so that we give that a name and we call it 10. This allows us to take the next bigger number and say, well, we've got another group of 10, that's the group of 10, but we have one more. So we've got a group, we think of this as a group of 10 plus 1, and we can write it as 1 times 10 plus 1 times 1, or 11. And we have to agree that the value associated with each of the places in this symbol, this number, are going to be known and agreed upon. So this right-hand one counts as 1. Each of these represents the number of 1s that we have. And this number represents the number of groups of 10 that we have. And we can go on with 12 and give this a name, 12, which represents one group of 10 plus 2. So now we have a scheme where we can represent this fairly large number of items, because it can be broken into 2 groups of 10, and so we'll put a 2 here, and there are 8 more, which is one of our numbers here, and 8 units, so we call this 2, 8, or 28, and that's the idea of the place values, at least as far up as we get to tens.